Welcome to your comprehensive interactive study breakdown of geometry and measures. This fundamental pillar of GCSE Mathematics tests your ability to understand spatial relationships, apply formulas, and construct logical geometric proofs. Mastery of this topic is crucial, as it often appears in high-tariff questions that separate top grades. We will explore angle properties, Pythagoras and trigonometry, circle theorems, and more. Let's map out the core concepts. First, angle properties. Know your parallel line rules exactly. Alternate angles are equal, corresponding angles are equal, co-interior angles sum to 180. Next, Pythagoras and trigonometry apply to right-angled triangles. The hypotenuse is always opposite the right angle. Circle theorems include cyclic quadrilaterals where opposite angles sum to 180, and tangents meet radii at 90 degrees. Finally, congruence and similarity are key for proofs and scale factors. Turning to our core study notes, the hypotenuse is crucial for Pythagoras and trigonometry. A right-angled triangle's longest side is always opposite the right angle. Regular polygons appear in angle calculations. Each interior angle equals n2, * 1/80. Cyclic quadrilaterals are key for circle theorem questions. Remember opposite angles sum to 180. Congruent shapes are identical, similarity uses scale factors. And a tangent meets a radius at a right angle, a common circle theorem. When tackling any geometry problem, follow this workflow. First, understand the shape and what you know. For example, if you have a right-angled triangle, decide between Pythagoras or trigonometry based on given sides and angles. Second, write the formula precisely. Third, substitute carefully, don't forget to square root for Pythagoras. Fourth, solve step by step. Finally, always provide a geometric reason if the question asks. Use the exact phrasing like alternate angles are equal, or angles on a straight line sum to 180. Let's work through a 6-mark exam question. Here we have a right-angled triangle with 2 legs given. The key is to identify the hypotenuse correctly. Using Pythagoras, square the 2 shorter sides, add them, and take the square root. We get exactly 10 centimeters. Note, even though it's exact, questions often ask for a decimal place. Here it's 10.0. Always check your answer makes sense. The hypotenuse must be the longest side. Watch out for common pitfalls. Always identify the hypotenuse first. In Pythagoras, it's opposite the right angle. In trigonometry, label the sides relative to the angle you're using: opposite, adjacent, hypotenuse. Never use SOHCAHTOA unless the triangle is right-angled. When giving reasons, don't say it makes an F shape, say our corresponding angles are equal. For similar shapes, remember length scale factor is K, area scale factor is K squared, volume scale factor is K cubed. To wrap up, memorize angle rules: alternate, corresponding, co-interior angles with parallel lines. Pythagoras requires the hypotenuse. Trigonometry uses SOHCAHTOA only for right triangles. Circle theorems: opposite angles in a cyclic quadrilateral sum to 180, and a tangent is perpendicular to the radius. For congruence, remember the 4 tests. For similarity, scale factors extend to area and volume. Practice these concepts with past papers to secure top marks.